All right, well, I apologize for that again, and we will go ahead and get started. We are doing an introduction to 3D printing for Christmas displays, and I'm going to apologize one more time because my husband's going to walk in the door in 10 minutes, and I have two Jack Russells. So if anybody knows what two Jack Russells sound like when a loved one gets home, I will try and close the door and shut the noise out. So just warning you. But we're going to go ahead and get started with this and the introduction for 3D printing for Christmas display. I started working on 3D printing probably several years ago, and it was very hard. I didn't have Facebook or anything else like that to help me, so a lot of it was learned hard knocks. But we're going to go ahead and get started, and our outline for tonight is we're going to discuss what comprises 3D printing, the history of it, some of the technology and the materials behind it, what a 3D printer looks like, some of the applications that you can use, how to get started. We will probably not print anything. This was a presentation that I had done for the Christmas Expo, and I did actually print something then. And then we'll talk a little bit about print problems and where you go from there. So 3D printing is called additive manufacturing, and it is probably the hottest thing that has hit since the internet. And it's the process by which you take a 3D model called an STL file, and you lay down many successive thin layers of material on top of each other to create whatever it is that you're trying to create. We have many varieties of 3D printing out there. If you see on this picture right here, we've got a 3D printed house where they're using cement through a nozzle, which is pretty cool. We have 3D printing with dentist, and that's a Herbst appliance, and I know that because my daughter had one in her mouth, and they use it to make models before they actually do stuff. 3D printing has medical and veterinary applications. If you see this toucan right here, they created an underbeak for him. And this turtle had lost his shell, and they created this shell to help him live. They actually painted it so it looked more natural, but I didn't get that picture. Sorry about that. We also have prosthetics, and they use 3D printing for hands, legs, digits, any number of things like that. So that's pretty cool application for there. And you'll see in the forums, a lot of people are trying to do 3D printing for their for prosthetics for their loved ones. This one's a really interesting use for 3D printing. It's food. There is a restaurant in England that does 3D printing of food, and absolutely everything in that restaurant was created with the 3D printer, down to the tables and the chairs, which is, I would really like to go and see that particular restaurant. So history of 3D printing, it made its way into the technology world in the 80s, but it didn't really get any traction until the 90s. And actually the mid 2000s is when it became more accessible for the end user like us. That was when the RepRap phenomenon took over, and it's an open source self-replicating 3D printer movement. Now, to explain open source real quickly, xLights is open source. It means people who understand how to do it, they can get the source code, they can go in and alter it, and they can do what they want to with it. And they did that with 3D printing. But self-replicating is, and I'm building a printer right here. I guess I should have tried to show it to you. Right now, this printer I'm building, I have printed with another printer parts to help create this printer, reinforcements, fans and whatnots. So that is where it is self-replicating. And you can take a part and create, you can figure out what kind of part you want to create, or you can find it on the internet and print it in just a matter of hours. So it's really fast, and it's a whole lot of fun. Normal technology does not use what additive manufacturing, where you take a layer and you build upon itself. They cut and they mold to create different shapes. This is not the print nozzle, and again, I don't have one with me to show you right now. Is what is used to create these multiple layers, and I've got a really small, fine print nozzle that I'm using. So the use of 3D print technology, they use modeling software, such as any type of CAD software, and they convert that particular file into flat cross sections, and then that produces the successive layers until the complete model is produced. And you'll see that when you go into your software and they call it slicing your software. You'll go through and you'll see how all the layers are going to lay out, and that way you can verify that it's going to lay properly before you send it to your printer. And this is called a WYSIWYG method, which, you know, everyone talks about WYSIWYGs when you do web development, but this is a WYSIWYG when you do CAD or 3D printing. The complexity of 3D printing. It is not plug and play, but then you know what? Neither is anything that we're doing with our Christmas lights. So this should not come to any surprise to you guys. There are a lot of steps that take place prior to pressing print. And this is not even talking about building or any of that other stuff like that. This is just getting the file to the printer and printing it off. So prior to the printer, you have to either design, hold on one second, guys. Husband's home and the dogs are getting ready to start barking. So prior to the printing, you're going to either design your part, or you're going to go and find it on somewhere like Thingiverse. You're going to prepare the file, you're going to convert it, and then you're going to send it to your printer. And after it comes off the printer, you're going to scrape it off the bed because it's going to adhere to your bed, and you might have some sort of raft holding it down to your bed, or you might have supports because you've got overhanging parts. So you'll have to remove all of your supports off of there, and the supports don't really make things pretty. So what happens after that is you go and you'll sand it down to make it smooth if you want to do that. And I do paint a lot of the things that I print. I have a whole lot of fun with mine, and I use an acrylic paint, and I make a lot of cool gifts off of that. So when we're talking about starting, think Thingiverse, and Thingiverse is probably one of the best places to find already made STL files. Some of them will work, some of them won't. You'll have to go through and you'll have to read your comments and stuff like that. And I don't just print Christmas light props. I print fun things. I print gifts. I print things to make my life easier, to help with my cell phone or help with my car. So 3D is showing a great deal of promise in fulfilling a local manufacturing model where products are produced on demand in the place where they're needed. So you want something, you find it, or you design it and you print it. So when you talk about what you're going to be putting through your 3D printer, there's a whole lot of stuff out there, and we're only going to talk about a small portion of what's available out there. I know that John and some other people use granules and rosins. I'm going to only talk about filaments today, and the two printers that I have only deal in filaments, and most of the beginner 3D printers are filament fed, so this will be right up your guys' alley. So the different types of filament or plastics, if you will, that you're going to feed into your 3D printer, your beginning 3D printer, if you will. One of them is ABS, and that's a good strong plastic, and it's used in a filament form. It's kind of fussy in that it requires a heated bed to be able to utilize it. So if you have bought a 3D printer without a heated bed, you're going to have a difficult time with this particular filament. PLA, that is probably the most user-friendly plastic out there, and that is what I use most of the time. It is a biodegradable plastic, and you can get it in a rosin form. It's got a variety of colors, but ABS also has a variety of colors. It's not as durable or as flexible as ABS, so I don't like to use ABS on like my clips that I use for my pixels on my roof, or any of those particular things. And then we come to Pet G, and Pet G is probably one of the best ones out there, and I have yet to master that, as John Billings will heckle me about. It does require a heated bed, but it's a really strong and really durable one, and in Florida heat and sunshine, it's probably one of the best plastics to use for outdoor use. So it's one of the things that I'm really working hard at mastering. Oh crap, I thought I fixed this. All right, everybody turn your head sideways because I'll have to go back into the file. This is my 3D printer, and I did have all this straight, and I don't know what happened to it. This right here is the bed of the 3D printer, and this is my x-axis. It's very much like a graph. When you did graphing in school and you had to do your x and your y's, this is your x, this is your y, and up and down is your z. Oh my goodness, I fixed this, and how did it happen? This is one of your stepper motors, and your stepper motors are things that will move your axis up or down or sideways, whatever that needs to do right there. This is your filament. This is my LCD display. This is my heated bed, and I've got painter's tape on it, but that's one of the things that I started using to help whatever I'm print adhere to my bed the best. And I'm sorry about that. I don't know why it did that. This is another shot of it, and right here where the filament is going in, this is my extruder motor. The filament goes into here, and then there's a little spring and gear right there that pushes it out the bottom as it's heated. And this is my hot end. That's where it gets heated and pushed out. By the way, it's really hot and it will burn your skin. And I think everybody who's had a 3D printer has burned their fingers on those things. So let's talk about, why would you want to do a 3D printer? Well, it's fun. It's definitely a challenge. It's unique. You get an immense amount of satisfaction in there, and it is a DIY thing. And for those of you who like to get your hands dirty in DIY, this is a great way of doing it. I have a lot of fun in there. If I'm not printing every day, I'm getting antsy, wondering what is it that I can print? What is it I can design? What is it I can do with my printer now? So let's look at it from the Christmas light show application, because there's a lot of uses that you can get out of your 3D printer for that. And that's why, one of the reasons that I really wanted to get into this. I have printed cases for my Raspberry Pi. I have printed mounting boards for my Falcon. I've printed cases for Pi players for the Pi Hat. I've printed parts for my power supply. I've printed snowflakes for pixels, just because I wanted to try it out and see how it's done. I will have to tell you, it's a whole lot cheaper doing it through Boscario. Just an FYI there. I have printed arch bases to hold the PVC pipe in place. Spokes for printers. I couldn't begin to tell you the number of different uses for there. And one of them, I'll give you a Facebook page in another slide where you can find more different things that you can use for your Christmas lights. And it's the 3D printing for Christmas light enthusiasts. And I've got it on a slide so you'll be able to see it. But they've got a file section in there that contains a whole lot of different things that you can use your 3D printer for that will help you with your light show. So how are we going to get started? Well, there's two ways you can do it. You can build your own printer, and that's a really cool way of tearing your hair out and learning things the hard way. It will take you at least 24 hours to build your printer, and I don't know how many more hours to get it set up and going, but it is very self-satisfying, and you will learn a whole lot about your printer and how it works, the different aspects of it. So when things do go wrong, you are very comfortable in tearing it apart and fixing it, which I'm really good at doing now. Or you can buy a ready-made one, and ready-made ones will run you 800 to whatever the limit is. And I think I've got a slide on that, so we can talk about that a little bit later. But my last printer that I'm working on building right now is a TiVo Tarantula, and I think I spent $150 on it. I am still building it, but it'll get there one day. So let's talk about building your own. RepRap.org is, and the RepRap machine is your, like I said, your self-replicating machine, manufacturing machine. So when you look at printer, one of the things that I like to look at is a printer with a large build area. That's the platform, the heated bed. That's probably one of the best things, because the larger the bed, the larger the items that you can build, and the less that you have to take things apart and try and build them together. One of the things that I like is a bed leveling sensor, and I've got two different ones that I'm working on. This new one is, we'll see how that one works. Oh, here it's called. It's called the BL Touch, and this is my first time using that one, and school's out on that one right now. You can talk about single extruders or dual extruders. Single extruder means you can only print one color at a time. A dual extruder means that you can print multiple colors at a time. A lot of these printers, when you look to buy them, find out if you can upgrade them to a dual extruder. That might be something that you want to play with in the future. Just understand that when you're printing with two extruders, you have to keep them both hot at one time. So one of them is going to be printing on the item, the other one's going to be printing over off to the side to keep the filament flowing and not clogging, but you're going to waste a whole lot of filament that way. And then the Raspberry Pi, and that's a really cool use for a Raspberry Pi, is building a little Octoprint server to run your 3D printer. You can monitor it via webcam. So when you're not at home and your printer starts going crazy and builds this big wad of filament up around the hot end, and you see it going on, you can stop it. And so it gives you the opportunity to actually leave and not have to monitor it. I have gone to bed and gone to sleep and woke up the next morning with my hot end completely encased in filament, and it had overheated and it had shut down. So the Octoprint would be a good option. Or you can buy one off the shelf, and we'll talk a little bit about buying one off the shelf. Like I said, it goes from $700 up to $12,000. Everyone has a favorite. It's kind of like ice cream. Everyone's going to tell you something different. There is this really cool website, and I've linked it right up here. It's called productchart.com 3D printers, and you can go in on the left-hand side. If you see, you can tell it what specs that you want off of there. For example, I want a heated bed. I really don't care about Wi-Fi. I like open source stuff. You can just narrow it down as much as you want, and every time you narrow it down, it narrows down the amount of printers that you will have to select from. So it will help you find a printer pretty quickly, and it was one of the tools that I liked using. You're going to need software to run your 3D printer. And the software that I use is a free software, and it's Cura. And Cura is it's a slicer, if you will. It will, it's where you're going to load your STL files. You're going to use the programs to define different aspects of your printer. You'll slice it to prep it for printer, and then you're going to output the G code for use in the printer. And I use my USB to run to my printer, but a lot of people really don't like running your 3D printer off of your USB connected to your computer because of different problems. If your computer loses electricity or shuts down or does a Windows stinking restart, your printer will stop. Even if it's 8 hours in, it'll stop. But if you use an SD card and plug it into your printer, you can pause it and do different things with it. So there are different aspects for doing that. The other software is 3D design software, and that will help you design the different things that you want to build. For example, if there's something that you want to put on your Christmas light display and nobody else has it out there, you can take something like Tinkercad and go in there and design your own thing and have it output to an STL file, run it through your slicer and print it. And it's pretty quick. Some of the tools that I like to work with, and everyone's going to have their own different tools, is glue sticks. Glue sticks will help you sometimes, like on ABS, when it doesn't like to stick to your bed, or PETG, it'll help your filament stick to the bed better. Tweezers are, oh my goodness, they are an absolute must. When you've got little stray filaments that get thrown down on your table, on your heated bed, or you can pull that stuff off of there. Scraper, that is probably one of the most important things that you have. My scraper looks like a cake frosting spatula. X-Acto knife and blades, that will help you clean off supports off of your print after you get it done. Calipers will be a really helpful tool to determine whether you're printing accurately or whether you've designed accurately. Painter's tape, I was using painter's tape for a long time until John Billings had me get this little thing that fits on top of my heated bed now, and it's a solid piece, so I don't have all those lines in my prints now, and it actually adheres better. Scissors, I use a lot. A Dremel I use to clean up some of my prints. And acetone. Acetone is one of those things, I think that it only really works well on ABS, and people take and print off of ABS, and they do what's called an acetone bath. They take their print, they put it on a sheet of aluminum foil in a container that has acetone on the bottom, and they close it off, and the vapors in there kind of melt the layers, and so it makes it really glossy and smooth. I think it looks melted myself, but a lot of people like the way that looks, so that is one of the tools that you can use. Tinkercad is one of, and I've got another 3D design software that I use, but I don't have it on the slide, so I will have to pick that up later. So that is one of the places that you can go. It's a web-based 3D design software. It is free. Most of the stuff that I use is free and open source. The other thing is go to Thingiverse. There's so much stuff there, and there's other places that host STL files, but Thingiverse is the most well-known one. You can go in there and you can do a search by Christmas, or you can do a search by Falcon Pi, you can do a search by Raspberry Pi case, whatever it is that you want, and you can see what's available in there. Make sure you go and read the comments on each one of them, see what other people have done with them, because sometimes they don't give you the particular settings that you would want to be able to best print whatever it is that they've designed. So to prepare to print, we're going to create the design or select it from Thingiverse. We're going to convert it. Then we're going to slice it with something like Cura or Slicer 3D. You're going to take the print. Now, sometimes when you got your item that you are going to be printing and it loads up onto like Cura, you look at it and it's not flat on the bottom. It's been stuck some strange way. Like I had one print, a Darth Vader print, where the Darth Vader was loaded on his head, and I rotated him on his back because that gave me the least amount of fill that I was going to have to use to support that item. So that's something that you're going to need to learn a little bit about, and that's going to take more time than I've got here today. You also have the option of being able to scale whatever object it is. For example, on my 3D printer that I was trying to print parts for, I printed them at scale, but they didn't fit on my printer very well, so I had to adjust the scale. So I made it 101 or 102% of normal until it fit my printer the best. When you're slicing it, you're going to check for defects. There's a number of different ways you can do that. You're going to go through there and you're going to look at it by layers. You're going to look at it to see what supports are needed. And your slicer will help you with that. But that's, again, something that goes specifically to the slicer, and that would be too much detail to get into for today. The correct resolution. Resolution is going to depend upon what it is that you're printing. Some items you're going to want to, you're going to want a very fine resolution. You're going to want a great amount of detail. Some items, but you don't really care if you've got a great amount of detail. So that's something that you're going to have to choose for each individual print. Your correct temperature range for the filament. The best way to determine what the correct temperature range is to look at the filament. On the side of every one of your filaments, it's going to tell you. For example, my Hatchbox uses a print range from 195 to 210. But the other toner plastics, I think it is, they use a print range from 200 to 225 for PLA. ABS is even higher. It's like 230 to 245. So look at the side of the plastic of your filament and choose that when you're setting it up in your slicer. Your correct fill density. For example, my Darth Vader doll that I was building, he didn't need to be really dense because I wanted him to be light enough to be able to manipulate, but I didn't want him to be too light that I could take him and crush him with my hands. So you're gonna work, and this is something that you'll have to play with. Rafts and supports. For example, my Darth Vader doll, he had 2 tiny feet when I had him stood up and I started printing him that way to begin with. And there's so much back and forth going on with the bed that those 2 tiny feet just didn't want to adhere to the bed. So for the next time I did it, I made him with rafts. So it's a piece on the bottom that it looks like a little flat disc that's going to go straight on the bed first, and then it's going to build on top of it. So the plastics are kind of melted together, and then you'll scrape the raft off the bottom, you'll peel it off, and then you'll have to sand down whatever it is that you peeled it off of. Before you print, the most important thing that you will ever do is level your bed. And every time you have a problem, the first thing that people are going to say is, did you level your bed? Did you check and make sure your bed's level? Because that is a big part of most of our problems. And that is something that you will have to learn how to do. You're going to prepare your bed with tape or some sort of adhesion. Some people use glass to print off of. Sometimes you're going to use the glue sticks to help adhere if you find that you're fighting things fighting a print staying too often, staying adhered. Then you're going to send your G code to the printer, either via an SD card, your Octoprint server, a FireWire, or a Wi-Fi connection. Oh, there's my little Darth Vader head that I was talking about. He was fun to print. And you'll see over here, this is my Cura software, and you'll see my layer height or my resolution, retraction, which is going to be something that helps you. Every time it moves, it's going to pull the filament back up so you're not dragging filament. How dense you want the filling. So if I want to crush him, I'll have, hardly anything. But if I want him really dense, I'll have 100%. And then there's a whole bunch of other settings that you'll pay attention to as you start working on your printer. But again, you're not in this by yourself. There are so many Facebook groups of people who want to help you through this. And then there's chat. People will help you through this. You're not stuck in it by yourself, very much like our Christmas lights. So again, the resolution is your layer height. I just pointed that out to you. Your fill density, 100% is a solid fill with 20% being about average. Your print temperatures, very important setting. If you've got that print temperature too low, it's going to under extrude. You've got it too high, it's going to over extrude. You're going to get a big blob. Check the label on your filament before starting your print. Your bed temperature is important. I do use a heated bed for my PLA. Some people don't. ABS, you've got to have a heated bed. Some sort of support structure. If you've got an overhang, for example, on my Darth Vader, overhang of over 45 degrees, you're going to need some sort of support structure, a build plate or something to keep, when it starts printing on this overhang, it just doesn't melt down. And then you've got your platform adhesion type, raft or brims. Those are your two prominent types. So you are going to have problems with your print. This is a learning process. Everything is. There's a number of different websites where you can go and you can look at what your print is doing and determine if it's like that. And then there's solutions under all these links on what might be the problem. Again, level your print bed is probably one of the most common ones. More print problems. Here's another link for a different place where you can go and take a look at. And one more for print problems. There's all kinds of information out there, guys. Google is your friend. Additional support. This is probably one of the my most favorite ones right here, and I'm going to get fussed at after I get off the phone, off the call with you guys. This Facebook group, 3D Printing for Christmas Light Enthusiasts. Make a note of that. Go and join it while you're on with this Zoom meeting, because there's a lot of good information in there. There's a lot of really good people in there. It does not appear to be one of those nasty groups where people chastise you or make fun of you for asking silly questions. And there's a wealth of information in their file section on items that will help you with your Christmas display. So I would definitely check out that. There's also Facebook groups for your individual printers. For example, I have a TiVo Tarantula right here off to my right. And before I even got my printer, I went and joined that Facebook group. I went and looked through their files, went and watched and see what kind of issues people were having, saw what kind of upgrades they were suggesting that you make for this particular type of printer, and how it would help me be a better printer for this. So I have built a whole bunch of stuff on this that did not come with my printer, and we're going to see if that works one of these days when I get around to finishing it. And that is it. Man, when I did this at Expo, I ran completely out of time, but I was doing demos with my 3D printer, and I do not have the capability of doing that with you guys right now without doing a whole lot of camera jerking around. So I'm going to open it to questions.